for main engine ignition. 7, 6. We have main engine ignition. 4, 3, 2, 1, 0, and liftoff. Liftoff of the Orbiter Challenger and the 6th flight of the Space Shuttle. The shuttle has cleared the tower.
Challenger's underway. We got a roll program.
Houston copies, Challenger.
The period of maximum aerodynamic pressure. 30 seconds elapsed. Throttles on all three main engines coming down to 81%. Velocity 2,000 feet per second. Altitude 3.5 miles. Downrange 2 miles. 1 minute elapsed. Main engine throttle is going back to 104%. Challenger is go at throttle up.
Challenger, you're go at throttle up.
Challenger, go at throttle up. Trajectory slightly depressed, no problem. Flight dynamics officer reports.
Challenger, Houston, we see you're slightly depressed, no problem.
Okay, Dick. Velocity 4,100 feet per second. Altitude 15 miles. Downrange 14 miles. Velocity 5,100 feet per second. 20 miles in altitude. Downrange 22 nautical miles. Standing by for solid rocket booster separation. SRB-7 was that something. We have an awful lot of crud on the windows at SRB-7, Dick.
Roger, we copy that. Challenger, your first stage performance was nominal.
Okay, thank you. Guidance has converged. Velocity now 6,000 feet per second. Altitude 31 miles. Challenger's 46 miles downrange. Flight Director Jay Green polling all positions. All controllers reporting everything looks great.
Hello, we're back with you over Hawaii for about 7.5 minutes.
Read you loud and clear.
And double check you got the TV and the ground command. Looks like you've got a missile in your bay pointed right at you.
If you look really close, you can see a hand in the starboard window. The glare is MS-1.
Okay, you want to give us a little short narration on what you think you see there?
Yeah, those two things sticking up look like, to me, like pieces of material, probably that new insulation we have on the Ohms pods. And they appear to be about 6 to 8 inches long, John, and it looks to me like it's a width of insulation. Probably, it's hard to tell from this perspective, but maybe 6, 8 inches wide that have been peeled up from the outboard edge. They're still attached on the inboard or, up toward the top of the pod. The thickness is about 1 inch. The bottom surface, is what we are principally looking at, is pink, about the color of our TV, and the rest of it's white.
Okay, that RTV is red. That does confirm one thing.
Challenger, Houston's with you at Mila. We have a TV picture. And still dropping in and out a little bit. bit, let it stabilize. Okay, that looks good. And no voice, Challenger.
Box. How's that, Troy? You read us all right?
Okay, read you 5 by now, and we have a clear picture.
Okay, Houston, we're going to start with the release of the umbilical and take you all the way through the deployment.
Roger.
Be getting a picture now.
Roger, we got a good picture.
Start the clocks. Okay, it's moving. Boy, it moves slow. It is slow. Here it comes. It ain't real slow at this end. It's coming up. Can't look.
God,
Go back
this
down
is
there.
absolutely fantastic.
Go back
How
here.
long have we waited for this?
Go back to your panel.
No, I don't want the panel.
The whole world is over at that panel over there. Just stay
The
there.
motion's gray. That's all I need to know. Look at that beauty. This line right here, from the 29
What
gets
line?
to this line. That beam right there.
Okay, we're almost there.
And Challenger, Houston, with you here at Hawaii for about 6 minutes. And Bo, we noticed in the crew activity plan that you're activating the gas, the getaway specials, and the nozzle. So why don't you explain to us earthbound mortals here a little bit about what you're doing? And you better do it good because Diane's up here behind us watching.
I see. There is the Japanese gas canister, which is investigating the production of snowflakes in orbit. And then the Park Seed Company canister, which is going to be looking at the space environment's effect on seeds. The middle one is from the Air Force Academy. And that has a half a dozen different experiments on it. There's a metal beam joiner, where they're going to try to join metals in space, a miscible alloy, a foam metal, a crystal purification, a microorganism development, and an electroplating experiment. The cadets at the Air Force Academy have been working on these for quite some time to get them ready for this flight on the shuttle. Looks like those gas canisters are, in fact, going to be running. I hope they get good results from them. I think it's a great opportunity for a lot of people, and especially for students, to be able to look at the environment of space and see how it affects all sorts of different items.
And mid-deck, you can pick up with a comm.
Okay, what I'm doing right now is getting close down to taking a photo here, about 4 minutes away, to photograph the entrance of sample 5 into the flow column in the Cephas here. Between now and then, there's not a whole lot to do except wait for it. Got the camera set up, and except for a few out-of-range parameters, Cephas is running pretty well today. We enter the sample right in here. The sample is injected down here in different ports here. It's carried up with a carrier there. I talking to the Space Shuttle Challenger?
Yes, sir, you certainly are.
Well, listen, first of all, congratulations on the continued success of your mission. I understand you're even ahead of schedule.
Well, we like to stay that way, Mr. President.
Well, listen, the Challenger proves again the quality of our technology and the versatility of the Space Shuttle. Serves as a symbol, I think, of our commitment to maintain America's leadership in space. But all of it would be without any merit at all if it wasn't for men that we have, like all of you, Commander Weitz and your pilot, Carol Bobko, and your mission specialist, Story Musgrave, and Donald Peterson. And I know that while one of you has been out in space there in connection with the space platform, the others, this is your maiden voyage.
Well, thank you, sir, and we appreciate that. I know it's an old and well-used saw, but, you know, we just get the glory. We really get to stand on the shoulders of giants when we participate in this program.
Well, you're pretty close to giants yourselves. Now, I know that I shouldn't keep you too long because you're kind of anxious to make that spacewalk out there. And we'll be all watching for that down here.
Okay, here comes the hatch.
Can you pull it in?
Yeah, I'm going to rotate around here.
Okay.
A little bit behind you. There.
Smile, you're on candid camera.
Challenger, Houston's with you over Guam for about 7.5 minutes.
Roger, hatch is open. EV1 is halfway out. They're configuring the airlock, getting ready for Don to come out.
That's great news.
Got it?
And Bo, if you got the sunlight, you need to use the spot meter also.
Don, I want to go to at hold now, so the next half a rev over the Earth will be toward the sky.
Oh, thanks.
We copy, PJ. Got a good shot of Mother Earth behind you there, Story.
A little deeper pool than I've been used to working in.
We're looking right at you, Story, with camera Bravo.
I see you.
It's a fantastic view.
There we go. That's what I wanted.
Okay, now we're going to see what the safety wire would do to me if I ever got loose. What it would do right here.
That's about 3 more, Bo. Can you go now?
Okay.
I think you can make it now, probably.
John, we're hung up real bad on getting the winch to winch out. We've been through it before with tension on it. Cannot get it to ratchet out, and we cannot get it to reel out.
We copy?
We've been through the usual fixes.
Story, is the winch rope attached to the IUS at this time?
Yeah, it is.
You can't get any slack in that line at all, Story.
That's right, not enough to get off the hook. Now, a good possibility is if I can get it off the roller up above, I'll get some slack that way. Okay, I got it. I yanked it off the roller. Now, before we do anything else, if it ain't gonna release, we'll get this match block undone. We'll know we're home free.
Not until you lift it over that hook.
Okay, guys, what do we got left to do out here? Bay looks clean.
I believe we've done it, Story.
But I think this mission of yours really does make a significant contribution to the whole effort, and it's most inspiring. And thanks ever so much for what you're doing. I'll now turn this over to the pros.
This project has been brought to you by the Geritol Bunch. F Troop. We didn't have a chance to rehearse this very well. Okay, we're very pleased to find this stashed somewhere in the vehicle. And it just goes to bring home that old adage, is that Space Whiz John Young has said that space flight is really for old folks. And, Bo?
That's great.
And maybe that's why we try a little harder.
Turn it down just a little to get the glare off of it. There we go.
111 years of aviation experience. All right.
We try to please.
official touchdown time at 5 days, 0 hours, 23 minutes, 42 seconds. We'll stop at 32 past the minute. Challenger's crew now exiting the spacecraft, coming down the stairs for perhaps a walk around, kick the tires before going over to the medical exam and the ceremony thereafter. Being greeted by JSC Director of Flight Operations George Abbey.